Hi, Christine here. Before we get on with the episode, we wanted to let you know about a very cool podcast that we think you should listen to.
Hi, my name is Jackie Oparafatoye. I'm the Regional Deputy Editor for SciDev.net. SciDev is the world's leading source of reliable, authoritative news, views, and analysis on information about science, technology for global development. Our mission is to ensure that science and technology has a central role and positive impact on sustainable development and poverty reduction in the global south. SciDev is currently managed by the Center for Agriculture and Biosciences International, CABI. About our podcast, The African Science Focus, it looks at science and health in sub-Saharan Africa and gives policymakers, development practitioners, academics, and the general public a weekly insight into the impact that science is having in Africa's least developed countries. African Science Focus offers researchers an opportunity to highlight their work to European and African audiences and gives African journalists a space where they can report on science. We want to enable journalists in these countries to speak about the impact of science on their own communities, and the podcast will give them a platform which allows them to take this message to the policymakers whose decision can impact on their lives. The African Science Focus is supported by a European Development Journalism grant from the European Journalism Center. You can listen to our podcast on our website, www.scidev.net. Our podcast can also be found on Apple, Spotify, Google, iHeartRadio, Listening Notes, Player FM, Podchaser, Podcast Addicts, and Overcast. We are on all social media platforms, Facebook, Twitter, Instagram, as SciDev.net.
And now, back to our regular episode.
Hello everyone! Let me guess, you are training to become scientists. From time to time, we question the significance of what we do. That's quite normal, especially in times of crisis. You must have heard people say that science should solve society's practical problems. Blue skies research would be a waste of public money. Yes, solving problems is crucial, but you cannot get the fruit without cultivating the tree. And a healthy tree needs strong roots. Fundamental research is the root of scientific knowledge. Every discovery made about life, the universe, and everything is like a piece that fits in an enormous puzzle. Most of the time, a scientist gets interested in a small part of that puzzle. Then, piece by piece, images start to appear in labs all over the world. One day, another generation sees the bigger picture and solves a significant problem. Who could, for instance, predict the fruits born of an unsuspected seed from the 18th century? In the old city of Königsberg, some nerds just wanted to know if it was possible to walk 7 bridges without repeating any. The solution to that puzzle gave birth to graph theory. Graph theory slowly grew to become network science. Now, this is a robust framework that allows planning transport in a metropole. It also provides an understanding of how interconnected neurons form memories. And, keep in mind, it even allows fighting an emerging disease, such as the current coronavirus pandemic. Those ancient nerds of Königsberg just wanted to satisfy their curiosity. They were not trying to save the world, become rich, or get tenure. Be like them. Search your feelings and find which puzzle motivates you the most. Ask simple questions about fundamental problems. Plant the seed and care for the tree. Good fruits will be a natural consequence.
Welcome to your Digital Mentor podcast. I am your host, Dr. Alice Matimba from the Welcome Genome Campus, Advanced Courses and Scientific Conferences. Today we'll be talking about simplicity. So as the famous saying goes, simplicity is the ultimate sophistication. But with all the advances in technology and, all these layers of complexity in nature, biology, and in the universe and all the problems of the world. Scientists are always out there to find answers to problems. So we'll be talking about how do researchers have a curiosity mindset in order to develop or to find simple solutions to complex problems. So joining me is Fredros Okumu. We'll be talking about how he applies his skills in finding simple solutions for local solutions for global problems on his journey to becoming one of the world's famous scientists, particularly in his field of research. So before we dig in, Fredros, would you like to just briefly tell us more about yourself and the work that you do?
A very good morning to you, Alice. Thank you very much for welcoming me to the podcast. This is fantastic. So my name is Fredros. I work for Ifakara Health Institute in Tanzania. I am myself a mosquito biologist, but I practice generally also in public health. Of course, simply I can say that I'm a mosquito biologist, working generally in the biology and control of infectious diseases. But I do also have a lot of responsibilities in looking after younger people who are interested in advancing their careers to be great researchers in future. And it's important, therefore, that the subject of simplicity that you are talking about today is looked at in much greater focus with regard to the question of how do we, as scientists based in Africa, create solutions that are most relevant for the problems we face today.
I'm glad that you already play a very important mentorship role with, upskilling young people. And I guess that's part of what you probably highlight during today's discussion. You work a lot in the field and you work a lot in trying to find solutions to complex problems, right? About how do you deal with this complex problem of malaria. As an academic and as a researcher, you always have so many ideas that you want to pursue. You have so many questions that you have. And as a researcher, you also are interested in finding or making important discoveries that are going to maybe make you famous, but much more importantly, that are translatable to something valuable, groundbreaking, and impacting society. Can you tell us more about what are your most prized simple innovations or discoveries which you feel have had a significant impact either in your community or even just globally or in research in general?
Well, Alice, as a scientist, we are having, and especially now, having to balance these two ideas of one, do you create a groundbreaking innovation versus do you address people's current needs, priority health needs in that case? And unfortunately, many scientists, including myself and my colleagues, are driven towards demonstrating their capability by creating something new, creating something revolutionary. And if we don't pay attention to that driver or that motivation, you run the risk of ignoring the dominant or the priority health needs that our society currently faces. And I think, therefore, instead of describing the specific big things that we have done, it is more important for us to discuss how have we contributed to the improvements of people's lives and well-being. And at Ifakara Health Institute, where I work, we have a very strong pursuit of the mission, which is improving people's health and well-being. We are a Tanzanian organization, yes, with a regional focus but international footprint. And we still very much believe that our biggest priority should be to identify and address people's priority health needs. And this does not necessarily mean creating something new. It might mean creating a new way of doing the old things. It might mean accelerating some of the things that we are doing. So I give you an example. At my institution, we have a small cohort of young people who work on an HIV clinic established in 2005. They have 11,000 patients in there. In our clinic, 90+% of all the patients who come to the clinic have undetectable viral load in their blood. They can no longer transmit the virus to their partners. Nearly all the mothers who come to the clinic can no longer transmit HIV to their children, even if they breastfeed. Now, of course, this is best practices. It is putting together the knowledge that they have as clinicians with some of the most advanced technologies and approaches of healthcare in a system that is very low income otherwise. And you could choose to say, okay, this is revolutionary. But in my opinion, it is really just like, how do you consolidate the scientific know-how that the young people already have to immediately begin saving lives going forward? And I think those are important opportunities for us to be taking instead of just waiting to invent something new. I mean, there's not enough space for 1,000 Albert Einsteins, but there's probably a lot of space for 20,000 young people to save, 1,000 lives each.
Yeah, that's a very good point, and actually resonates quite well with me. I've come, a long way to realize this. So I was always doing research, trying to do, use the latest technologies, for example, in genomics. And after having done all that, and after having gone and done your postdoc, and you feel like you're right at the cusp of doing great discoveries, when I, returned back to my home, I actually realized that all that was not so important. What was important was to deal with what's really, of immediate importance and benefit to the people local in the community. And so one of the things that I realized was I didn't have the background, for example, is it in public health or in that type of maybe clinical background, but I had certain skills that I had picked up by doing my PhD or by being trained as a researcher. And so I wondered if this is something that you see that a lot of the, you get trained as a researcher, you also have the skills to do other things that are not necessarily related to your high-tech science that you've been trained in, but you can actually apply locally. How do you see yourself kind of applying? What are some of those skills that you've really benefited from, where you use that to bridge the gap to address some of your local community challenges?
Alice, this is an important point you raise. I think if you study in highly resourced labs, you can choose to be, and you can survive as, shall we say, a hedgehog. You can very much focus on a single subject and be the best at it, and that's okay. However, if you're working in Africa or in some of the settings such as where I work, it helps a lot to be foxy. It helps a lot to, of course, have your area of focus, but also know a little bit about everything else in your surroundings. And the reason I say this is, as a young graduate of a PhD, you return home and the first thing they do is make you head of department. And of course, I mean, if you stayed in London or other big league universities, what would normally happen is at that stage, people would still give you time to build your career, become an expert in a certain area, not bog you down with administrative duties, not ask you to start supervising students, not ask you to start doing administrative meetings with communities and government officials, XYZ. But working in Africa, these are skills that you must build already from very early on. You must not only be a very good scientist in whatever genomic sciences you're doing, but must also learn public engagement skills, must also learn leadership skills, must also be an accountant to manage your grants and manage your finances. All these are important for the overall growth of not just you as an individual scientist, but also the entire ecosystem that we must create for the continued growth of additional scientists in that ecosystem. And so I think that you can look at this as a challenge for an African scientist or a scientist in a less endowed lab, but you can also use it as an opportunity. You can also view it as an opportunity, rather, where people get a chance to grow much more comprehensively, all-rounded, not just on a technical basis, but also develop several other soft skills that are necessary to build a sustainable ecosystem for future research going forward. So I think in my case, one of the beautiful things that I've benefited from, I finished PhD in 2012, and at that time I asked myself, what skill really do I have? And even if I have that skill, how applicable is it? So at that time you realize really it's just this time to begin learning. And it's time to begin learning not only on your technical area, but also on these other soft skills that I'm talking about.
Yeah, that's really a good point. And in fact, I was just, reflecting on, a lot of ongoing discussions in Africa or in other low-resourced areas. Researchers are usually kind of complaining about, oh, we don't have any funding, we don't have any infrastructure, or we don't have the right mentors. And I think that attitude of people feel paralyzed by not having all those things. How can we make sure that we empower our young researchers to become more resourceful, not only in just their own personal lives, but actually in developing their research careers, despite not having all those things?
You're right. And in fact, I mean, you mentioned a number of challenges there. And this is not unique to just one setup or so. There are things that you find nearly in all countries. And in addition to that, you also have, very generally a massive glorification of individuals over teams. So in some of these teams where you work, regardless of how much work you do as a young scientist, the person who takes the glory is still the team leader. You have inadequate financing. Most of the African governments are not putting a lot of money in finance in research. So the scientists are having to compete for external funding from, let's say, UK or the United States, and they're competing with other scientists in countries that have other priorities. You have things as lack of flexibility to be able to do basic sciences or exploratory work, which are essential for future solution finding. If you look at diseases such as tuberculosis today, this is one of the most dangerous diseases in Africa. The best medication we have today is it's about 30 years old, and the medicines are still up to 6 months of therapy. And so you need solutions to get this. But to do that, you have to do a lot of basic science, which unfortunately we still don't have the ability to finance. You talked about the lack of supervision. This is not just important, but I actually think is critical in the sense that without a good teacher, without a good mentor, without a good supervisor, however you want to describe it, it's almost like being an orphan in a scientific community. It's almost being parentless. And so one of the things that you really want to invest on is to ensure that you have a very good ecosystem that provides all the things we have talked about, but most importantly, that provides mentorship in the system, that provides guidance to the young people. And I think this is really, really important for us to address the challenges that we have now and to really take the next steps to ensure that African science is building and that African scientists are able to address the problems we have now, but also to get ready to start doing a lot more innovative stuff that will be useful for the future and which we must also start working towards. And just one more thing that I must add is some labs might be lucky that they already have a critical mass of experts. In one group, for example, you might be a cancer researcher, and in one institution you have 10 other cancer researchers. And in many low-resource settings, that is not the case. You probably have one or two. And so one of the things we can benefit a lot from is to maintain the partnerships that we have had with institutions abroad or other institutions elsewhere, so that those connectivities or connections with other experts, regardless of their physical, geographical positions, those partnerships can still continue to help building this going forward.
So I guess, there's a lot that needs to be done from obviously different stakeholders, institutions, senior scientists, to keep up that momentum and help the young researchers. So I just want to bring you back to, the issue of just simplicity or making your research practice, maybe simplifying it so that, one, you can be able to understand it. So sometimes, you can do a whole lot of complicated stuff that even you struggle to understand what you're doing or how you're explaining to other people. And secondly, so that even when you do finally accomplish it and you have to translate it or use it or whatever, that it actually can be easily translated. So in fact, this is something that I was watching a talk by certain serial entrepreneur from the USA, Jeff Copps, and he was talking about radical simplicity, which is the art and discipline of reducing a problem to its sense so that you can be able to solve it in a practical, real world. So earlier on, you were talking about how at your institute, you have been able to solve a big problem, for example, in HIV. And to me, that sounds like what you want is to have a simple solution, right, which is now yielding those kinds of results. So how do you approach your work, for example, in malaria? How have you applied this kind of sort of radical simplicity where you see your intention is to eradicate malaria? I think that's the easy thing, that if somebody says, well, what do you do? I do research to eradicate malaria. But then you obviously have to do a lot of other things in the background to make this process clear and get to where you want. How are you doing this for malaria, in malaria research?
It's often said that our ability to solve a problem depends on our ability to articulate it, to explain it. And big problems usually are complex in the sense that they are made up of many, many small problems. Now, these subcomponents of this big problem are not all equally important. Once you break down a big problem and identify its subparts, you will realize very quickly that some of these subparts are more important than the others. And so, as a scientist, we have to very carefully select the subparts that are most important, but are also small, and attack those, pay attention to those, and incrementally solve these problems going forward. So sometimes, of course, if you have a lot of money, you can choose, for example, so let's use the example of malaria that you talk about. For me to be infected by malaria, the basic biological principle is that a mosquito must bite me, and that mosquito must have been infected. So for me to be infected with malaria, or for me to get malaria, I must be bitten by a malaria-infected mosquito. That is the basic biological principle. Now, if I want to solve this problem, the simplest way to do is to ensure that nobody ever gets bitten by a mosquito. So, depending on where you sit on this globe or this beautiful world of ours, you may choose to attack that problem using whichever tools you have. Some people sitting at NIH lab in the US might choose to go the genomics way. People sitting in I don't know where in Switzerland might choose to start looking for, screening for molecules that could one day result into some medicine or whatever. But if you're sitting in my village, I will ask myself, what is the simplest way to stop a mosquito from biting me? Knowing very well that from a biological basis, it will achieve exactly the same finding. And it might just be like, you know what? I've got to live inside a good house, a house that never lets in a mosquito. And I have to live in an area where there are no mosquitoes breeding. In other words, I have to remove all the water bodies where mosquitoes breed. Now, those are two simple things that anybody with or without a PhD can do. If done well, they will achieve exactly the same finding and probably better findings than the result that will come from the genomics lab or from the pharmaceutical screening lab. Now, the reason that people choose one approach over the other, we can discuss those reasons later. But if you ask me, when you look at a problem as a whole, and malaria being one example, you can slice and dice it into small subparts and very quickly figure out that there are some of those subparts that can be addressed at local level with the local knowledge, with the available resources, very expeditiously and very effectively. And that is what we try to do in Tanzania, to say, instead of focusing on the high-tech stuff, instead of saying, I must be a genomics specialist to be a scientist, no, we say, no, what is the simplest way, the most scalable way with which we can address this problem? Of course, we realize at the moment that we are sitting in an ecosystem, in an international society where people are kind of very interested in a certain way of doing things, and so our approaches might not necessarily be acceptable. But we are driven by the belief that we are doing what is right, and that our mission is to improve people's health and well-being. So if you see me in the village running around looking for water bodies where mosquitoes are breeding, I am as good a scientist as someone who dresses up in a white lab coat and enters an NIH lab in the UK or the US. We might not have the same resources, but the outcome, the mission is exactly the same. And perhaps we have capability to reach the goal much faster and in a much more scalable way.
Wow, and I think this is actually a great lesson to, even to some of us who, probably struggled for a long time to realize that whatever it is that you're doing, as long as you're doing it for the right reasons in the right place, and having the impact or having the effect, like you say, it doesn't matter whether it's cost billions or it costs much less. It's just about translating whatever knowledge into a solution that works, right? You've really nailed it, and I think this is exactly what I was hoping we would actually get more into. So you mentioned that in your institute you have quite a number of young researchers, and obviously mentored by you and others in your institution. I was wondering if you yourself have for you to kind of like have this really methodical approach to the way that you explain things and you approach your research. Is it something you were trained on, or you mentored on, or were you just naturally like that like-minded person?
Well, first of all, thank you for your kind words. But I think that, okay, let me put it this way. I haven't seen any curriculum in any university that teaches you the real life situation. Many of these things are best taught on the job. You learn as you go. You must be willing to practice the little that you know and learn the stuff that you still don't know. So, in other words, the amount of stuff that we do not know will decrease as we grow. So, it's mostly about experience and learning on the job. Having said that, I think it also depends so much on our willingness to take on new ideas, willingness to borrow practices from other people, willingness to observe, and willingness to listen to our key stakeholders, including the communities where we work. So we know after several years working with my colleagues, both senior staff and young scientists at Ifakara Health Institute, we know now that if you want to create an effective ecosystem for young researchers, it is not about the money and it is not about what so and so is doing in institution XYZ. It is not about publishing in Nature or Science. It is nothing like that. It is really just like having a dedicated workforce with a joint mission. And in our case, it is improving people's health and well-being with the understanding that this is a very, very long journey that all of us have committed to. Now, once we have that established, all we need to do is to create a very effective mentorship and supervision system in place. This itself is work in progress, but it is necessary that we have this good parenthood, as we call it. You've got to have good parents for your young scientists in the system. So effective supervision and mentorship. You've got to have very, very regular and strong interactions between your scientists and the communities that you aim to serve. And this could be patient groups. This could be target populations or communities in your villages. There could be government officials. But without these interactions, you can just stay in your cocoon as a scientist and never really learn what the real life is. In technology, there's a lot of interest in drones, for example, the use of unmanned aerial vehicles. And all of a sudden, people think, oh, if you have drones, you can do anything. But you see, I'm sitting in the villages and I'm like, should I bring drones to spray insecticides, or should I ask all these jobless young people in the village to do the job? Of course, I will choose to give this job to the young people in the village who are jobless than to bring a single drone to do the spraying. And the reasons for making that is really listening to my colleagues and not just adopting a technology because it's fancy. You have to have these very flexible, semi-autonomous leadership structures where even the youngest people and the most junior people in the group can have a point, they can have a say. And I think that's very, very important to have an almost horizontal leadership systems. Because in Africa, in Tanzania, where I work, at least myself, we are not always lucky to have all the experts in the same place. And in fact, even in universities, we still have this system where the School of Engineering is 100 kilometers from the School of Biology. So it's very difficult to get people to interact. Fortunately, with virtual systems, we can now get scientists to interact a lot more. And I think those are important. And then in addition to that, once you have a good administrative system that instead of just focusing on profit and loss, it also focuses on the future growth of your scientific community, and without forgetting gender and all that, and making sure that both your female and your male scientists are well taken care of. With all those things together, that I do not see why you would not create an effective system. Of course, I have to say that it all still depends on how this system is evaluated, and this is work in progress, of course. But for me, if you have a shared mission and the people in that system share in that mission and are willing to practice, there's really nothing that is impossible to do that.
Wow, I wish I had I had learned this when I was still interested in developing a research career. I think that the fact that you're able to just to be resourceful, to use what you have in front of you, right? Like you're saying that a lot of the solutions don't necessarily always require high tech, but you'll find that some of us in the work that we do a lot of training people in genomics and so forth. And quite often if you ask them, so what stops you from applying what you've learned? And a lot of the times they say, because we do not have funding, we don't have infrastructure. It just brings back the question of, when you're training researchers, you're training them to be able to have the ability to be resourceful and to find solutions with what they have. But we find that it's becoming hard. It seems it's becoming harder and harder for researchers to identify these skills or resources, because everyone is looking up to the richer countries or to the richer labs. And when they see what the other labs or the richer labs have, they suddenly think, oh, I can never really do research. So it's great to know or to see that, there's some places where you're trying to instill that level of sort of being resourceful and working within the communities.
It's an important point you bring, and I think it boils down to the existing value systems in the scientific community. And it will take some time to be streamlined. But, many of us find ourselves in this system where to be considered a great scientist, you must get a publication in, let's say, Nature, or a publication in Science. You must get $1 million of a grant XYZ. You must have a collaborator at Imperial College or have a collaborator in an NIH lab. Now, we are tied into this because those value systems were created by Western communities. But you see, we could have a different way of doing things. And we could say that I am a good scientist if I can identify and address priority health challenges of my people. And usually all that requires is a few good people, a few good women and men willing to share in your mission. And then you can find resources and put that to give them that. That does not necessarily have to be a lot of resources. So if we change the value system a little bit, I think that the future can slightly change. Now, I have to recognize that science is expensive, that whether we like it or not, we are going to have to, improve, to adopt some of the advancements that have already been created in China and in the West. And that's important, but it's a gradual process, and we should not necessarily just expect to leapfrog and ignore these developmental processes. I also believe, as you were saying earlier, that simplicity is key. So as long as we can slice and dice these challenges, there is a big proportion of our current challenges that can be addressed without the high-tech stuff. There is a big proportion of our challenges that can be addressed without millions of dollars. There's also a substantial proportion for now and for the future that will require these advancements, and this we must be cognizant of as well. But really, it's just about the value systems that we are living within and how we fit into those systems, whether we adapt or adopt them entirely or choose to do something slightly different.
Yeah, absolutely. And I think it also comes back to, you mentioned earlier that you don't learn these things. It's not part of any curricula, or probably maybe even less so in Africa or in places where there is probably less mentors or people to look up to. So we could wait for things to change gradually. That could take a very long time. Or do you see this as an opportunity to embed it in the curricula that's currently there, so the research curricula that is there, or even university and so forth?
Yeah, I don't know what to say about curricula, but at a very personal level, I like guidance, but I don't like to be tied to specific curricula. And the reason is that a lot of learning depends on how the person being taught responds to the teaching. And everybody is unique. So, my father was a teacher, and his training was through what at that time was called in-service training. So he started teaching as someone who never had a teaching certificate. He finished high school and just started to volunteer as a teacher. And after many years, he went and got a certificate as a teacher, but he would do that during the holidays and come back and teach and all that. But I thought he was a very good teacher. It was in-service training. In my own career, a lot of the things that I have learned, I never learned them in class. And of course, I recognize that I'm still learning and I will continue learning. But most of the things, I learned them by doing. I learn them by making mistakes, by practicing. So if we were to do a curriculum, it would have to be something very general that does not restrict people into a certain way of doing things, but rather teaches people to be flexible, to innovate, and to take advantage of their ecosystems and their environments. And to say, here I am, this is the environment I have, these are the resources I have, these are the people around me. What is the best that I can do to address the problems we have today and problems we might have in future? And so you are really talking about here about modeling your brain or training your mind, reorganizing yourself to take advantage of the situation. This, I doubt that you can learn anywhere. I think that we just need to tell PhD students or master students or postdocs or whatever that your technical expertise is only one aspect of your life as a scientist. You must remember always that you have a responsibility beyond your technical knowledge. And so go into the whole world and study how to live with people, study how to help people, study how to make yourself useful. So when you become the best genomic scientist in your laboratory, you must still be the best person outside your laboratory, because in the end, we are first of all human, and then we are scientists. And the human part of us mixes with a lot of other humans that have problems or no problems, or resources or no resources, and knowledge and no knowledge, and that we can tap into that humanity only if we expand and put in front our human side alongside our technical side. So it's difficult for me to prescribe a certain training or a way of training. I really think just let your scientists know that they have a responsibility, that this world depends on them, and that being technically good is not enough. It's not what we want from you. We want you to be a human, and a helpful human who has some technical skills to begin with, but can expand going forward.
Yeah, that's really important. So, what I've learned here is, as a scientist, make sure that you understand that your technical skills are equally important as your human side or your personal skills, and therefore you should nurture them together. This is quite profound. Actually, I've never really thought of these things sort of like together. That you have to be practicing it. You have to be, probably also starts with you being aware of, like what you've just mentioned, that it's not just me doing my research, writing papers, getting publications out, and that kind of stuff. And then the excellence which comes out of it then comes out as a bonus, because you're molding everything into your research.
Correct, Alice. And sorry for interrupting you, but I just want to say, and I mean, I say this recognizing that a lot of our audience is not African, but as an African, we have very innately in us the mutual social responsibility. I think in some parts of Africa, they call it Ubuntu. And it is not anything that you can go and learn. You were born with it. You just need to nurture it. If we create an ecosystem that kind of ignites this responsibility in us, many of us grow up in families that have, some kind of an extension. They're not nuclear families. You usually have, a sister or a brother who you have to take care of, or a mother or a grandmother, or what. You go to people's funerals, you contribute, you share food, you eat together, XYZ. It is exactly the same spirit that I am saying our scientists must bring into the research system. So if we send our scientists to go and study in the United States, we hope that they build good technical skills to bring home, but we also hope that they do not lose their Africanness, or they do not lose their Ubuntu spirit, that they do not lose their mutual social responsibility.
We're going to take a quick break and hear from our sponsors. We'll be back soon. This episode is supported by Advanced Courses in Scientific Conferences, a program which develops and delivers training and conferences that span basic research, cutting-edge biomedicine, and application of genomics in healthcare. Through engaging and networking, the events educate, inspire, and transform careers worldwide.
This episode is also supported by the Wellcome Sanger Institute. It undertakes large-scale research that forms the foundations of knowledge in biology and medicine. It uses the power of genome sequencing to understand and harness the information in DNA. The Sanger's discoveries are used to improve health and to understand life on Earth.
This episode is also supported by social entrepreneurship to spur health. The SESH group uses crowdsourcing to enhance health and health research with a focus on low and middle income countries.
So we're now reaching the end of our segment. Fredros, it's been lovely, hearing from you. And please share with us some key take-home messages around this discussion that you want to share with our audiences.
I guess I would say simplicity is key. Simple science is beautiful. And there is room for us to analyze a problem, however big it is, and dice it and slice it into smaller chunks that can be addressed in small ways using available resources. So if you are lucky to have as much resources as we need for the wholesome tech, please do so. But even if you don't have those resources, remember always that there's a lot that you can do with the little that you have. The money, the people, the communities around you, the administrative structures, the institutions, that you can help create simple solutions to address priority health needs for our people. And as long as we share in the mission, in our case, it's improving people's health and well-being, we can harness the beautiful aspects of simple science to address these major challenges that we still have. Otherwise, thank you guys very much, Alice, and thanks to your colleagues as well for hosting the show today.
Thank you, Fredros. That's some really wonderful take-home messages. And I'm just going to ask you to share where our listeners can find you, any social contacts on Twitter.
There is only one Fredros in the planet. There's two Fredroses. There's myself and my little son. So I don't think any other person has that name. But anyway, I'm not on Facebook. I'm available at Ifakara Health Institute in Tanzania. And I also tweet as well. My Twitter handle is Fredros Inc. Fredros_Inc. And that's my Twitter handle.
Great. And for our listeners, thanks for tuning in. Please follow us on Twitter, mentor_podcast, where we'll let you know when new episodes are released. You can listen to us on YouTube, Spotify, Apple Podcasts, Google Podcasts, and SoundCloud by searching Your Digital Mentor Podcast. You can also now reach us by email at inquiries@yourdigimentor.net. And as always, information on the episode will be in the description box, including how to connect with our guests and also links to more information and resources. And finally, our goal is for this podcast to be shared as a resource, so please remember to tell people about us. Thanks again, and see you in 2 weeks.